just let us know and we will help you work out the new idea if you're having issues with it. Yeah, so just, it's not set in stone. This is a practice for making proposals. Make it clear, let us know how you got to the idea and what the significance of the idea is. The sample proposal is about 4 pages. You can limit it to about 1 to 2. Yeah. Cool, thanks.
Is there a late deadline for the proposal? Like a late deadline? Like a grace period, 3 weeks?
I can't. Is there a definition for the proposal? That's actually a really good question. I think the 3-week grace. Let me check the timeline because it might. I think it would be an issue for when they start final projects. Okay.
There's only like 6 weeks left.
Does that include anything? Okay. Yeah, okay. I think most of it. Because it's, but isn't this the last week? Yeah. 12 hours with Clarence. Yeah, okay, guys, differently from past assignments, the proposal's only gonna have a 1-week grace period, so just turn it in before spring break. Let me know about any extenuating circumstances, we'll work through it, don't worry. Thank you. And now, off to Mira.
Okay, we're gonna start plotting today. I also can't talk like super loud. So if you think you're gonna have issues hearing, just like move up. There's like a ton of empty seats. But this week we're gonna start plotting, which means we're also gonna change our like coding environment from VS Code, which we've been using since the beginning of the semester, to Jupyter Notebooks, which are really good for plotting stuff and a little bit more intuitive to use than like a traditional text editing scripting environment like VS Code. So let's get started. This is our plotting lecture. Here are like some cool plots you can make using Python stuff. I think the one on the right uses either Seaborn or Plotly, but the one on the bottom left corner is the black hole picture that I'm sure all of you guys have seen, which was actually like visualized using some of the methods we're going to cover in class today, which is pretty sick. So the tools like feel really simple like right now, but you can do so much with them. And feel free to like check out the documentation for like so many things that you might pass out. So the library we're gonna
in progress.
I'm also recording. So the library we're gonna be using today is called matplotlib. It's called that because it borrows a lot of the functionality from MATLAB. So if you're familiar with MATLAB, it's the same thing. If you're not, if it looks kind of ugly, that's probably why. I don't think we need to do this because we're going to use Jupyter Notebooks, but if you want to use matplotlib in like VS Code or something like that, you would have to install it like we did for NumPy and go through all of those amazing installation steps again. But for now, let's look into using notebooks. Are these the right, am I using the right slides? Okay, I don't think these are the right slides. Hold on. Okay, these are the updated slides. I was like, it's missing something. Okay, so this is how we like open, this is how we open Jupyter Notebooks like on your computer, your personal computer. This is how you do it. If you have Mac, I'll like show that one. If you have Windows, go open Anaconda prompt. If you've never opened it, you can just search for it in your little like search bar. Just type in Anaconda prompt and then click on it when it comes up. And it should be like another terminal window, like what you use for Git and all that stuff. And then for Mac, just open up your terminal and then we can get started. So give me a thumbs up once you've opened up either Anaconda prompt or your terminal, and then we'll do it. Not getting a lot of response from the back. Can you guys hear, or have you not opened it yet? Okay.
I'll walk around.
Okay.
That's not what I wanted to do.
Okay, stop typing and stuff. I'm gonna type it in and you can watch. Because you have to type it in a very specific way. Terminal, I use Mac. Make it really big. This is a command you want to put in. You have to spell it with the PY like it's Python because we think it's funny. No dash, you can put the space. The space is okay, it's allowed. And then you need the S at the end, I think. Nope, I got it wrong. No S at the end. Jupyter notebook. Singular notebook. You're not allowed to have more than one. And then it should do a bunch of stuff by itself, then open this. Does anyone want to see it again? Okay, I'm gonna do it again. No.
Is that just how your thing starts?
Yes. Okay, so you open up your terminal or your Anaconda prompt. It has like a line with some symbol of, it's like a $sign or a %sign, some symbol. I'll make it even bigger. I'll make it so big. Okay, it's huge. I'm gonna type exactly this and just this. Jupyter notebook, singular, you only get one. One notebook and you have to spell it like that with the space. And then you hit enter. And then it does a bunch of automated stuff.
Yeah, you have access to your whole computer on your web browser. Whoa.
This is so cool. If this didn't work for you, like you typed in and it was like, what are you doing? You might have to reinstall, like uninstall Anaconda and reinstall it.
Stuff, so.
So hopefully it's fine. You can do that like later. You can also like open it from the this little green guy. Anaconda's super slow, so I don't recommend doing it like this. You can open the little like Ouroboros Anaconda logo. And then from like in here, once it loads its slow ass, you can open it right here and just click launch. So this also works. It's way faster to just type it in your terminal. But both are fine. Or you can do what I did, which is I just found the batch command and I put it in my doc. But whatever works is fine. As long as you get to here, it's all good. So from here, this is like what we did with the command line where it's like, this is the structure of your computer. So what you need to do now is pick somewhere on your computer that you want to put your little code file. So I'm gonna put mine in my desktop because this is where I put all of my code files. So just pick somewhere for it to go. Mine's gonna go in my folder called Python decal, which is inside of my Burke folder on my desktop. But just like anywhere you want it to go. And then once you're there, I'll wait like a second for you guys to like click into somewhere. And then we'll make our notebook and it will be very exciting. Okay, I'm assuming we are all present and current in a place on our computers where we can put a code file. So you go to new, and then you're gonna click Python 3, IPy and click this one. It says notebook. That's how you know it's the right one. Bam, and then it looks like this. This is the whole code file. It should look like this. It should have a title that says like untitled or something. I had mine's untitled 1 because I already have one called untitled because I forgot to title it. But name it something. And then this is where you're gonna write all your code in like this little box. And then we'll like show how to like run it and everything in like a second. Did anyone like have issues getting to here? It's okay. 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 Okay, great. We all made it. That's very exciting. Back to the slides, our favorite part of all of this. Okay, we did this part. I talked about this already. This is how we actually plot stuff. We don't have to install matplotlib because it's already in the Jupyter notebook. It's like we're good. But this is how you use matplotlib to make graphs and stuff. This is called the figure sandwich. I don't know if this is like an official term, but we use it because you should always include these 3 things when you're making a plot. Charlie, you have like a super long statement.
I don't know where the room.
This one's wrong. He's a great person. Okay. Number 1, the top of red. plt.figure. This is like the first part that'll like make an empty like space on your notebook. I don't know what that was. On your notebook for a graph to go. So you should always include this. This plt.plot will like get into detail on like what this is later. But this is like the actual plotting your data in like a line or a scatter plot or whatever the hell. This is where you do that part. And the plt.show is like the last thing you need to include. It is the bottom red. You should always include this too, because if you don't, weird stuff will happen. So always include this, and then always include this, so your plot is like self-contained. And then when you do other stuff later, it doesn't get all messed up. So remember this, the 2 breads, and then the middle stuff. And then we're good. Okay. More plot stuff. You can like take a picture of this if you want. That would probably be a good idea because I don't have the slides uploaded yet. So you can see it's our sandwich is present and accounted for. plt.figure. We plotted our data somewhere. We did something with it. This is a line plot. Then we put our. That's what my mom said to me. Give it a title. This is exactly what it sounds like. And then we label the x-axis. And then we label the y-axis. Useful, always do this. Because then when people look at your plots and there's no labels, they'll be like, what is on here? You should do this. Legend, if it's appropriate, if you have like multiple datas on one plot, add a legend. And then you show it, the bottom grid. Good workflow. Sandwich, self-contained plot. Good. Other classes will tell you if you do all of these things. So good, it's good to like internalize it now. This is how you make a good plot. Okay, demo time. Let's make a plot. And it will be fun. And you will enjoy it, and that is a threat. So here we go. So I took a picture of the demo, now I need to pull it up.
I just have to put up with good person.
That'll be okay. All right. So if you guys remember like what we did with like NumPy, we gotta import all of our stuff. So for this, we're gonna want, is this too small? Let's make it bigger. Oh, that's too big. Okay, we imported NumPy. You want matplotlib as well. So kind of similar to NumPy where we were like MP is kind of like the standard alias for it. PLT is like the standard alias for matplotlib. And the reason for that is because I did it wrong. And no one wants to type in all this nonsense every single time they want to plot anything. So you give it an alias and then it's so much faster. But you need the matplotlib.pyplot, like that whole thing needs to be imported at the top. And then the way that you run code in Jupyter Notebooks is you can click the little run triangle up here. This works fine. It is faster and also you look cooler if you press shift and then return. And then that'll run it. And you know that it ran because if you look in like this top corner, that like open white circle thing that says kernel idle, when you run a cell, it'll like fill in. I didn't do it because I just ran this. It'll like fill in dark gray, and then when it's done running, it'll like turn white again. So if you're like running something and then you're like, why is nothing happening in your kernel? It's just like grayed in. It's like doing the task. So this is like something important that you should like kind of keep in the back of your mind when you're using Jupyter notebooks, because it tells you if your computer is running anything. So that's useful. We ran our code, great. So now let's like actually make a graph. So let's make some like fake data first. Let's make some like y values. Let's use our NumPy functions, which we're hopefully like a little bit more familiar with. And let's just like make an array of numbers from 0 to 99. There's 100 numbers total. And then, actually, sorry, let's make this x. Like some x values. 0 to 99 integers. And then let's make our y's, or like arbitrarily. I think it would be very fun and cool if we made them sign. So let's take the sign of every single one of those x values, and those will be our y's. And then let's run this. Either my computer is really fast or I didn't run anything. I'm assuming my computer's very fast. We hope. Okay, let's plot. Someone tell me what the first step in plotting is. I just told you. Yes, plt.figure, let's go. Nice. We have bread number 1. Now we want to plot it. So plt.plot. This is like the line plotting function. There's a lot of other ones. We're going to do this one for now. And then you give it x and you give it y. Beautiful. Now we need the rest. We're going to give it a title. I'm going to call it sign because it's kind of, there's not a lot going on. We're going to give it a title anyways, because we follow good practices when making plots. And then we're gonna label the axes too. And we're gonna call them X. We're gonna call them Y because again, there's not a lot going on. Yeah. Yeah, they always have to be strings. All these take string arguments. So you gotta put something in quotations. There's some exceptions. You can like feed in arguments like variables, but it has to be a string at some point. So these are like words. These are like, I'm gonna give the plot a title that is consisting of words. So you give it strings. Okay, what's the last piece that I told you guys we needed to do every time? Plot the show, let's go. Okay. That was pretty good. We have the breads and then all of the middle stuff. So, yeah.
Yeah, multiple variables, we should specify what to show.
If you like, you mean like multiple like y's per x?
Yeah.
If you have multiple y's per x, you would just like put them, let's say we have like a y2 that's like cosine. You just put that in here. And then when you show, it'll like show, plot.show shows, it like displays your graph with everything you put into the plot function and then all the bottom stuff. So this would show like all of the y's. Okay, so let's run this and we're gonna hope I did it right. And I did, look at that, amazing. It looks a little bit like jaggedy on the top because we used integers for x, but she's beautiful. Yeah. They're empty because we chose not to give them arguments. We can totally put an argument in here. You can do like, this will like make my graph like a very specific size and you have to format it like that, but that's optional. We don't have to do it. Yeah. Any other questions? And then plt.show, I think also has arguments, but I've never given it a single argument in my entire life. So you probably also won't have to. It shows everything that we did between the figure and the show. Right. Great, we made a graph. Very good. Let's go back to the slides, everyone's favorite part. Is there a question like in the very back?
Hey guys, while the lecture is going on, can you keep the conversation to a minimum? Always feel free to raise your hand for questions. While you're talking, please. keep it.
No, it's a, yeah, there's a lot of. Because my other cat was concerned. And we were in the rain. We didn't have a nice view. It's like, and that was like all the rains about anything else. Yeah, exactly. So my mom's just like, all right, go get your new car.
Okay, let's keep going. More graphs. We made a simple plot together. It was very fun, and you all enjoyed it very much. Let's talk about more plot stuff. What if you want to make not a line plot? Totally doable. The plt.plot, where's my great personality stick? plt.plot, line plot, what we just did. plt.scatter, scatter plot. That's how you do it. plt.bar, bar graph. Very self-explanatory methods. There's like hella other of these. Like hist or histograms, stuff like that. You can look at them in the documentation. You'll probably be using like plt.scatter and plt.plot, like by far the most. But if you're wondering if you can make like some weird plot using matplotlib, the answer is almost definitely yes. So documentation is your friend. But this is how you do it. It's not that hard. We as a collective can figure it out. These are the common ones. More stuff you might want to do to make your plot look good and also be more useful. Because if you remember, like the goal of plotting is to like display your data in a way that's interpretable to someone who hasn't seen all of your data analysis stuff like you have. You want to make it like really clear, and so people looking at it can tell what is on there and the clear patterns that you want to show. And so good ways to do that are changing the line styles to more clearly show the differences between your different Y values. I wish it's sick of the bottom. That's like your mom.
God.
It's too short. But you change the color. You put it in there. That is color is red. That's how you do that. There's like shortcuts. You can set the color of the line to be red. I think before it was like blue or something. The default is blue. You don't have to do all that. Question?
Is there a way I can Think about a specific shape.
Specific shade of red? Yes. If they do color code red, you can also like specify the RGB value. As like a parentheses tuple, it's like the red, green, blue value.
You should show them the list of the colors on that one.
I should.
It's so good.
Ridiculous. Yeah, we'll look at all the colors in a second. So you guys can also, like me, have an aneurysm looking at it. Lots of colors, so many colors. This is a little shortcut I told you about. I actually never use the shortcuts because I forget them every single time. And I just do color equals red. So you can also change the size of the line. Because I think the default line size is like really thin. So if you want like a big fat line, change the line width. It doesn't have to be a string, I guess. I didn't know that. I thought it could just be a number.
It can just be an, I don't
Yeah, I don't
feel-
think this is supposed to be a string. I think that this is just supposed to be like 20.5. So ignore the quotes. You can change the line width to literally anything you want. If you make it too thin, you can't see it. And if you make it too big, your entire plot will be that one line. So be judicious. You can change the marker type. So like for a scatter plot or a line plot, like your actual points are a default, like they're like circles. But if you wanted to like be really funky and fresh and use like a hexagon, you can do whatever you want. Like this is star-shaped markers because why not? Okay. Make your plots fun and have a little bit of whimsy. Can be
The
stars.
only time we get to.
You can do upside down triangles. It's amazing. And then you can also change the color and the marker because we're getting really crazy. So this is red stars. Amazing. Beautiful. And then if you wanted to change the opacity, like get like color lines and you want to like stack them. Alpha is like the opacity parameter. It's like 0.5 means it's like 50% transparent. So if you're using like a red line, it'll just be kind of pink. If you have more lines, it will be like kind of transparent. So this can be like pretty useful and like everyone always forgets about it. But this is an important one. Actually, all these are important. You should remember all of these. So feel free to like take a picture or just like pour it into your brain, whatever works better for you. Slurp it in. Whatever your preferred method of remembering syntax is. More plot customizing. Okay, I showed you the fix sizing like super quick. This is like you change the size, like when you do plt.show, it shows like a little box. plt.fixsize will like set the size of your box. So if you have like a plot and it's like really thin and really long for some reason, you can be like, none of that. And then you set it yourself. This is like, I think this is like height and then width. You should try both and see what happens. I forget every single time. But it's like a rectangle, like the sides of a rectangle. So for some data, like you have a really compressed y-axis between like 0 and 1, and then like a really long x-axis between like -10,000 and 200,000. And you're probably going to want the x dimension to be a little bit wider than the y dimension so you can like really see everything. Otherwise, it's going to be like really dense. That's a good time to use this. The default, I think, it's like 10 by 8 or something, so like pretty square. Usually want you to change it, in which case you can do plt.figure like empty, nothing in there. The only time I've ever put anything in is to set the fix size. You can add error bars. This is like a little bit advanced, but it's good for like physics and astrophysics stuff where you need to show your error in your data. You make your plot and you call a function called error bar, and it'll go to like each of your points and you give it like a list of errors for each point, and then it'll like plot the errors as like a little this thing, like the little X-wing looking thing on the point. So this can be also super helpful if you're doing like physics or like astronomy research. Good one to know. Format is like kind of like the point style, like what we did earlier. Every function has like their own little argument. Okay, so let's do it. Back to the code. All right, we're back. Let me pull it up on my phone. All right, let's make a graph that is fancy and cool. Not like the other one wasn't cool too, but we can do better, okay? So let's make x2. And I feel like using np.linspace for this one. Do we know what that is? Did we teach np.linspace? Okay, so let's use it. I want to make 100 points between 0 and 2 pi. So I'm gonna leave this as an exercise for the audience. Do your best for 26 seconds and then I'll do it.
So, for 26 seconds.
I was just gonna count in my head. The 8. Keep going. One 100. All right, it's been 26 seconds. Because I counted in my head and I just got to 26. So did anyone do it and wants to tell me how they did it? I'm sure most of you guys did it. I forgot. Please tell me how to do it. Did anyone do it? I give you 26 seconds. Yeah? Nice. Perfect. This is exactly right. Amazing. 100 points between 2 and np.py. Very good use of the 26 seconds. Okay, let's make our y's. And then let's do something like not very interesting, but it feels good to me. So we're gonna square all of the x's. Because that feels good to my soul. I feel like squaring them. Yeah,
Why do you think it X2?
because I want to square these,
Oh,
all these.
very unlikely.
Yeah. Okay. If you name variables different things from me, then you will have to compensate accordingly. All right, let's make our graph now. So let's run this first. And then now let's make our plot. Someone tell me what the first thing I do is. Figure. Let's give it a fix, sorry. Let's pick some numbers that really speak to our souls. I'm feeling like 7.3. We're gonna find out. I actually don't know. I'm feeling 7.3. We'll see if this works. And then the other number, I'm feeling 17.
That's so big.
It's not gonna fit on the screen, but we can try.
It's gonna be great. Let's see what-
We're gonna keep going. I'm not gonna test this. We're just gonna keep going. Because exactly. It's the anticipation, you know? Is it gonna work? I don't know. Okay, next line. Let's plot our data. We're just gonna do a line plot. Give it our X and Y's, our new cool X and Y's. And then you guys, let's pick a color. Oh my God. All right, list of named colors. These are all the boring base colors. But we want a cool color. Let's choose from here.
So many.
If you guys want to look at this, just Google the same thing I did, which is matplotlib colors. Lots of colors. Does anyone have an immediate preference? These are tiny. That didn't do anything. They're so cute. I want to know who picked mint green though.
That's like what?
I know, it's so pale. Um,
Thistle?
Thistle, all right.
Yeah, use thistle.
Nice. Thank you.
Good job.
Okay, we picked a color. That was the hardest part. We picked a color. And then we should like also set like a cool marker. This is the second hardest part. We need to set a cool marker. Let's look up all the cool markers. Marker is like the thing you put over the points.
That's important.
Yeah, so like one type of marker was like literally nothing. Like when we did the earlier plot, it was just like a straight line. There was like no cool, awesome marker. It was just a line plot. We want a cool, awesome marker. As you can see, there are a lot of possible ones, like this one. You can turn it in any direction you want. Except, yeah, you can do it down. Yeah.
Great. Love it.
You can do plus filled. You can do X filled. And then these are just like boring lines. But caret left, caret right, caret up,
Is that how you
caret
spell
down.
carrot?
Yeah, it's not carrot like the vegetable. If you just learned that, yeah, it's not like carrot the vegetable. But you can center it anywhere you want, apparently. You can center them anywhere at the base. So many possibilities. Or if you want to be really boring, you can do nothing. That's not interesting. Is there any marker that is speaking to us? There's so many. Maybe one of these interesting ones. Which one? Try up. All right. Sounds good. Try up is cool. Okay, let me see. Where's the documentation for the actual? This is the documentation for the plot function. As you can see, it kind of says you can do whatever the hell you want. Star args means that there's like a bunch of extra stuff you can put in. And when that's like the first argument, you know it's gonna be crazy. I mean, you can do whatever you want. And then usually they'll like be nice and give you some examples. So like here's some stuff we talked about. Color equals green, marker equals O, line style equals dashed. We should choose a line style too. But we set the color and then now let's set the marker. So I think it was called,
There's an underscore.
there's an underscore. I was like, tree up doesn't sound correct. Okay, try up. And let's set a line style too, because we're already at it, you know, we're already getting crazy. Let's go all the way. I think so. We're gonna find out.
We are learning so many new things today.
Let me look up if that one exists. I just kind of like made it up. Hmm. I was so close. There's no underscore. God damn it. Okay, it's okay. This one just sounded cool. So we did the hardest part, we set the color. And then we did the second hardest part, we set the marker, and then we put in the actual data. And then we did the easiest part, which is the line style. But okay, now let's do like the rest of it or whatever. Let's set the title. Okay, looks good. Let's try and run this, and we're really gonna see what happens with that first line because I gave it a decimal, and I don't know if it can take decimals. No, I messed up something else. Oh wait, so the decimal worked
That's what we're.
because it errored later. Where did I mess up?
Oh.
I forgot a comma. Bam. Put that bad boy in there. I left him out. I'm very sorry. It was my bad. But we have him now. Oh, and it aired again. Okay, what happened? Okay, we got the marker name wrong. I guess so, yeah. All right, let's go see what it's actually called.
It's.
Two. It's called two. No, that was my
my
bad.
God.
It's called two. So let's go fix that. All right, let's give it two. There we go. Look at that long ass plot. Amazing. And the color is really light.
Let's make it bigger. Market equals.
It's just 2. Okay, let's set the line width, you guys, because it's, and also I'm gonna make this not so tall. Because I can't see it. So we're gonna change that to 10, and then we're gonna make the line thicker. 50. Because we need to do big numbers to see what happens. Run it. Look at that, y'all. Look how useful this graph is. You get, okay, so like the reason it looks like this, let me make this not as big. Make it 20. This is, okay, it's still too tall. I need a 4. All right, now we can look at it because my thing is so zoomed in. It looks so weird because I chose the dash dot line style because it spoke to me. So all the like the places where it's like a thick line is the dash part, and like the dots are the dot part. And then we have so many data points. We did 100 between 0 and 2 pi. That all those like little tiny points in there are all of the actual data points. So this is a terrible graph, but I mean, I like it. I love her. I think it's okay. But we did all like the main stuff. Line style, line width. This is obviously way too thick. I mean, never too thick, but maybe a little bit too thick. We changed the color, the most important part. We chose the marker style, the second most important part. And then we gave it data, which is like the least important part. All right.
Yeah, David? Yeah, what's up?
It looks like this. This is like the final iteration. I don't think it's better than any of the previous iterations, but this is the one. You can.
Yeah.
Why did you say that? Should we set a marker with? No, well, let's not do it this time. This is good enough. This is good enough to make amazing plots like this. Okay, let's move on. If you you can just take a picture if you haven't like read all of it. Okay. Moving on. These are the wrong slides. Okay. This is everyone's, including my least favorite part about plotting. I hate subplots. I hate them so much. But if you want to plot multiple stuff on one graph, have it be like really close to each other, which is like all the time you want to do this, you have to use subplots, which again, I hate them so much. But we are going to practice because I think you have to do it on the homework. And so we should suffer through it like right now. So when you do the homework, you can suffer like a little bit less, but you're still gonna suffer because these suck so much. Anyways, what is a subplot? You make your PLT figure and then you're like, I want to put like 6 things in here. I have my data that's like slightly different for all these different things. I want them all to be really close to each other so you can directly compare all of them. Subplots. I don't know, there's no picture, it's just a planet. But you know what I mean, we saw them before. This is one of the like 13 different ways to make subplots. There's so many ways to do it, and I hate every single one. But this one works. So like kind of the key plot is this like, where's my stick? Okay, so there's actually 2 ways to do it. But you need some kind of like tuple over here. Some fig, like this is the name of your figure. You can call this anything. Fig is like should. Use fig, okay? And then this can either be like a tuple of like, this is x1 and x2 because this is a subplot that's 2 subplots. If you wanted to do like a 2x2 grid, you do like x1, x2, x3, x4. We'll go over it. But this is like the dimensions of your subplots. So like it's like a grid of subplots, right? If you want to do like 3x4, you specify that in this part, like how you want it to look. This is saying like 2 right next to each other, side by side. Yeah. And then you call the PLT subplots, and then 2 over here is like the total number of plots. If I was gonna make my like 3x4, this would have to be 12 because I'm making lots of plots. This is the other way to do it. You don't give it like the specific dimensions, and you just give it some generic name for your like individual plots. So fig is like the whole group, the whole grouping, it's like the canvas that they're all like plastered onto. And then the Ax1, Ax2, or just that AXS variable is like one of the individual little guys on there. So important distinction, fig is like the whole thing, and then axis is like the individual little pieces. Okay. Fig that soup title, it's for like subplot title, but like it looks like soup. So title your soup. This is like, it goes over the whole top. So you call it vertically stacked subplots. I guess I was wrong. This is two plots, one on top of another. Title. And then if you want to plot it using the format where you didn't specify the shape, you'd have to index it like you did with lists. You see it right? Location numero uno. Plot this. But for the other one, we chose that like the first location was on X1. Same thing. And then you plot the second one. Same thing. Okay. This is a quick introduction to my least favorite thing about matplotlib, in case you didn't notice. But let's do it. Oh my God. Okay. Back to it. We have 3 minutes. I think we can do it. Okay, we're gonna make like a 2x2 grid because I feel like it. That's how you do it. We're gonna do this the first version where you don't specify the size in the beginning. Because I like this one better. Okay. We're gonna skip the soup title because bad practice, but I don't care. Okay, location 1. It's a grid. So we can think about our 2D indexing that we did earlier with lists and whatnot. So the top left corner is going to be 0, 0. This is the same indexing that we did with like NumPy 2D arrays. And if you did like indexing on 2D lists, which I think you did, same thing. We're going to use the X and Y that we defined earlier because I don't have time to make new ones. This is the one on the first row. So the first number is the row, the second number is the column. So I think, might be wrong. I think I'm right? Yeah, row column. So first row, second column. So this is going to be the top right corner of our 2x2. We're just gonna like keep mixing and matching the stuff we already did. So second row, first column. So this is the bottom left corner. Jesus Christ. And then this is going to be the second row, second column, bottom right corner. 6, geez. There we go. I'll show the code again, but you should get like a little 2x2 grid of stuff. And we're done. It only shows the top 2 because my thing is so zoomed in. But it should look like that. A lot of places to make errors here. But this is like the most straightforward way to do this that like I found. Again, there's like a ton of different ways to do it. I recommend this one. And that was the last slide, so we made it. Okay, great. Yeah. Yeah, so each of these is their own dot plots. You can change the best part, the color, and then all the other stuff like in here.
After Wednesday, which is more plotting, we'll put ultimate plotting guide up on B courses.